Right now, there's a good chance a piece of paper is within arm's reach of you. A receipt, a book, a delivery box. It's so ordinary we barely notice it, but the material itself started as a tree that took 30, 40, sometimes 80 years to grow. In about a day, a paper mill turns that tree into something this thin. There's also a myth about what happens to paper after you're done with it, a myth that turns out isn't quite true. We'll get to that. First, let's see how a tree actually becomes paper. Paper as we know it isn't a modern invention. It was invented in China around the year 105 AD by a court official named Kai Lun, who macerated mulberry bark, hemp, and old fishing nets into a pulp and pressed it into thin sheets. It took over 1,000 years for the technique to reach Europe. The core idea, turning plant fiber into a thin bonded sheet, hasn't really changed since. What has changed is the scale. It starts in a forest, usually one managed specifically for this. Fast-growing plantation species like pine and eucalyptus, planted and harvested on a 10 to 25-year cycle, not old-growth forest. In a managed plantation, new trees are typically replanted the same season a stand is cut. The trees are felled, stripped of their branches, and trucked to a mill. At the mill, the first machine strips off the bark completely. It's not needed, and it would contaminate the pulp. What's left is fed into a chipper that shreds the logs into pieces about the size of a coin, half an inch to an inch across, giving the next step far more surface area to work with. There are two ways to turn wood chips into pulp. The mechanical method grinds the chips against a rotating stone, physically tearing the fibers apart in water. It's fast and wastes very little of the wood, but the fibers come out short and weak, which is why mechanical pulp is mostly used for newsprint, not the paper in a printer. The other method is chemical, and it's what makes most of the paper you actually use. Wood chips go into a massive pressure vessel called a digester, along with a mix of chemicals called cooking liquor. Under heat and pressure, that liquor dissolves lignin, the natural glue that holds wood fibers together, without destroying the fibers themselves. That distinction matters more than it sounds. Lignin is what makes a newspaper turn yellow and brittle in sunlight. It's still full of it. Chemically pulped paper has that glue removed, so it stays white and holds together far longer. After cooking, the pulp is washed to remove the spent chemicals, then bleached, not with the bleach you'd use at home, but with a sequence of oxygen and chlorine-based compounds that lighten the fibers in stages without weakening them. The clean pulp still isn't ready. It goes through refiners, machines that brush and fray the individual fibers, which is what actually lets them bond to each other later. Skip this step and the paper falls apart in your hands. Depending on what the paper is for, other ingredients get mixed in at this stage too. Calcium carbonate or clay is added to make the sheet brighter and smoother for printing, and starch gets added for strength. The paper this script might be printed on, and the cardboard box your last package came in, start from almost the same base pulp. The difference is mostly in what gets added, and how thick the final sheet is pressed. At this point, the pulp is mixed with a huge amount of water. The slurry that goes onto the paper machine is about 99% water and only 1% fiber. That thin slurry is sprayed evenly onto a fast-moving mesh screen called a Fourdrinier wire, named after the two brothers who financed the patent over 200 years ago. As it moves, most of the water simply drains through the mesh by gravity, and the fibers start to knit together into a continuous, fragile sheet. The sheet, still mostly water at this point, passes through a series of heavy rollers that squeeze out more moisture and press the fibers tightly together. From there, it runs across dozens of steam-heated cylinders, sometimes over 100 of them, each one drying the sheet a little more as it travels through at highway speed. The last stop is calendaring. The paper passes between polished rollers that smooth its surface and set its final thickness, before it's wound into a roll that can weigh several tons. That's also why paper comes out so different depending on what it's for. Tissue paper is dried fast and left loose and soft. Printer paper gets extra coating and calendaring for a smooth surface that won't let ink bleed. Cardboard just uses a much thicker, less refined sheet, with almost none of the bleaching. That roll gets sliced down into smaller rolls, or flat sheets, depending on where it's headed next. A printer, a packaging plant, a notebook factory. Because so much wood goes into this industry, sourcing matters. The FSC, or PEFC logo, on a paper product means the wood came from a forest independently certified to replant what it cuts. The scale of all this is hard to picture. Mills like the ones in this video run continuously, day and night, and a single large paper machine can turn out more than 1,000 meters of finished paper every minute, faster than most cars drive on a highway. Globally, the industry produces over 400 million tons of paper and cardboard a year, and packaging, boxes, and boards, not the paper in a printer, now makes up close to 2/3 of that, mostly because of how much gets shipped in cardboard. If you've got this far, this channel is probably for you. Subscribing tells YouTube to keep sending them your way. And stay for this next part. It's where the story turns. The paper that does make it back into the system follows a completely different path than the trees we just watched. It's collected, sorted by grade, cardboard separate from office paper, separate from newspaper, and compressed into dense bales. At a recycling mill, those bales get dropped into a giant vat called a pulper, mixed with water, and agitated until the fibers separate from each other again, and from whatever ink was printed on them. Getting the ink out is its own process, called de-inking, and it's stranger than it sounds. The pulp gets mixed with soap-like chemicals, and air is pumped through it from below. Ink particles are naturally repelled by water, so they stick to the rising bubbles and float to the surface as a dark foam, which gets skimmed off the top, almost like scum off a soup. What's left underneath is clean, usable fiber, ready to go back through the same paper machine as before. Now the myth. You've probably heard that paper can only be recycled 5 to 7 times before the fibers get too short to use. That number gets repeated constantly, but it's not really a fiber limit. Researchers who tested the same batch of fibers through 25 recycling cycles in a lab found no meaningful loss of strength. The real 5 to 7 number comes from somewhere else entirely. In the real world, paper and fiber get lost at every step of collection and processing, not because the fiber wears out, but because not all of it makes it back into the system. So how much of it actually comes back? In Europe, the number for 2024 is 75.1%. The year before, it was 79.3%. A 4-point drop in 12 months looks like something went badly wrong with collection. It didn't. The amount of paper actually collected and recycled barely moved, down 0.4% to 53.4 million tons. What moved was the other half of the fraction. Consumption jumped 5.2% to 71.1 million tons. The recycling rate is a ratio, and Europe didn't get worse at recycling. It just used more paper. There's a second thing hiding inside that number. Of the 53.4 million tons collected, 6 million, about 11%, were sold to countries outside Europe. For years, most of that went to China, but Chinese demand has fallen to close to zero. Today, the big buyers are India and Indonesia. Strip the trade out and count only the fiber that goes back through a European mill, and the rate drops from 75% to 66.6%. Same paper, same bins, different question. It's a different story from glass, which we covered on this channel. Glass genuinely can be melted and reformed forever with no real degradation. Paper's limit is more about logistics than material science, which matters because making a single ton of virgin paper uses around 17 trees and over 20,000 liters of water. Recycling that same ton back into paper uses a fraction of both. If you want to understand how the things around you are actually made, subscribe. There's something new here every day, and twice a week we take a whole process apart from the ground up.